sometime earlier this week. If you have not received yours back, send me an email and I'll reply to you with a copy of your test. Sometimes because I do an ink right on the test, right on the computer screen, sometimes when you open them up, if you don't have the latest version of Word, you cannot see the ink for me grading it. If that's the case, try to open it up on one of WITC's computers and you should be able to see the ink on it. If not, let me know and I can just send you a list of what problems you lost points on. Now that you have the tests back, you can redo the problems you got wrong and turn them back in and get up to half your points back. So let's say you had a 70%. If you redo it, that gets you back up to an 85%. When you redo those problems, just make sure you show your work as you're doing them. Now, for those of you in New Richmond, if you only have a few wrong and you don't want to have to rescan the whole test and send it back to me, you can just type it up in an email, problem number 3, show the steps or whatever, and just send me the problems that you had wrong that you need to redo. But make sure you do that. If you don't know for sure what to do, feel free to work with a classmate or to get help from anybody you want to. If you need to, contact me and I'll help you get through the problem step by step. And the main point for me to do that is I want you to at least see how to do it correctly before we move on. And usually I give you a couple of weeks. So if you have those done anytime between now and our next unit test, that'll be fine. So those don't have to be done like right now today. Since I mentioned our next unit test, by the way, that will be 2 weeks from today. So that's coming up pretty quick again. Okay, so to the problem I had up here for you to start out the class, how much 38% solution would you mix with 120 milliliters of 58% solution to create a 46% solution? So in here, remember, we have to ask, what is it that we are mixing? And what is our desired result? So there's always 2 that we're mixing together and to get 1 desired result. So what 2% are we mixing together here? Of the 3 in the problem, what are the 2 that we were mixing together? Well, it's generally the largest and the smallest, because when we mix them, we're going to get something in between. Now we're asked, how much of the 38% would you mix with 120 milliliters of the 58%? So those are the 2 that we are mixing, is the 38% and the 58%. So the result that we're hoping to get, or we're trying to get, is 46%. Next, we have to know the amounts. And we only are given 1 amount in this problem, 120 milliliters, which goes with which percent? The 58, good. We have 120 milliliters of the 58%. So we can let X be either the amount of the 38 or the amount of the 46. It's easiest if we let X be the amount that we're looking for. How much of the 38% solution is what we're looking for? So we'll let X be 38. So then how much of the 46% solution would we have? Yeah, X plus 120 or 120 plus X. So now the amount of active ingredient that we put into the solutions has to be the amount that we get out in our result. So the amount of active ingredient, remember, is the concentration times the amount. So for the first part that we're mixing in, the first solution we're mixing in, the 38%, concentration, 38%, it becomes 0.38. We change it to a decimal, times X, plus, for the next solution, 58% becomes 0.58 as a decimal, times the volume of 120, equals, so when we add those 2 ingredients together, we have to get the total active ingredient, active amount in our result. That's going to be the 0.46, so from the 46%, times X plus 120 is that amount. So to solve this, we're going to first reduce whatever we can on the left side of the equation. So 0.38x doesn't change, 0.38x. 0.58 times 120. Okay. 69.6. 0.4 over here, we got the parentheses. There's nothing we can do inside them, so we're going to multiply by the 0.46. So 0.46 times x is 0.46x. 0.46 times 120. 55.2. So now I've reduced everything that I can on each side, but I notice that there is still an x on each side of the equation, so I have to get rid of one. So I'll get rid of the 0.38x on the left. That's the smaller one. So I made that look like I was dividing, but really I'm subtracting 0.38x. So on the left here, the 0.38x is gone. I'm left with 69.6. On the right, 0.46x minus 0.38x is 0.08x. And we still have the positive 55.2. And now we're in our form of equation that we know how to solve. So we can just go ahead and subtract the 55.2. That's gone. 69.6 minus 55.2 is 14.4. Now we'll divide by the 0.08. Get x by itself. 180. So x is 180. So now let's go back up and make sure we've answered our question. So x was the amount of the 38% solution. It's going to be 180 milliliters. The question asks how much of the 38% solution. So yes, the 180 milliliters is our answer. That's what we were looking for there. How many of you had that one right? How many of you are heading in the right direction? I just didn't give you enough time. How many people are really frustrated by these problems? A few of you? Okay. And that's totally understandable. When we first start these out, these are very confusing. So don't feel bad. Stick with us. We're going to do more examples. We're going to change it up a little bit. We're going to ask how much I'm going to throw an abbreviation here. NS, remember, stands for normal saline or neutral solution. Basically, all it is just sterile water. So how much NS would you mix with 240 milliliters of 28% solution to create a 21% solution? In other words, we're just diluting it down with sterile water. We're not adding any sort of a active ingredient to it at all. So again, you've got to look at the two things we are mixing together, and then what our desired result is. And I always start out with the percents. Obviously, one of the percents we're mixing is the 28% solution. Doesn't matter whether I put it first or second. The other thing that we're mixing together is the sterile water. What's the concentration of that? How much medicine does it have in it? None. So that's 0% concentration. And the desired result, we're trying to create 21% solution. So we're mixing 0 and 28, trying to create 21%. Looking at our amounts, we have 240 milliliters, which describes which one of those? 28. Good. Which one should we let be X? Well, we're asked to find how much what? 0 water. That's the amount of the 0%. So then the amount of the 21% is going to be how much? Perfect. We're going to add together these two amounts to get the total amount. So it's X plus 240. So our equation for each ingredient, we're going to take the amount of active, or for each of the items we're mixing, we take the amount of active ingredient. Well, 0% is 0.00 times the amount of X. 28% is 0.28 times its amount of 240. So that's the amount of active ingredient that's being put into this mixture. So the amount that's in the result has to be the same. Concentration is 21%, so 0.21. And the amount is X plus 240. Now when we go to simplify this, on the left side we've got 0 times X. That's just 0. So that's gone. We have 0.28 times 240. $67.2 equals, over here there's nothing to do inside those parentheses, so we're going to distribute the 0.21. 0.21 times X is 0.21X. 0.21 times 240 is 50.4, I believe. So now, because the 0x disappeared, we're down to only, the variable only appears once, so we're ready to start solving this equation. So we can subtract the 50.4, which will give us 16.8, equals 0.21x, and we divide by 0.21, which is going to give us, what, 80? X is 80 milliliters. So again, we should go back and double check to make sure we've answered the question. X is describing the amount of the 0% solution. And we were asked how much of the NS, of the sterile water. So that is what we're looking for, is the amount of that 0%. Any questions? So the key, again, is to break the problem down. And I always write it out just like this. I write down the percents that I'm mixing together and the percent that I want to be my result. And then I write down my known amounts. And I know that this amount plus this amount has to equal the final amount. So if I know any two of those numbers, I know the third one. I'm going to ask a little bit different question this time. Say if we need 360 milliliters of 61% solution. How much (64%) and how much (49%) solutions should be mixed? So we're looking for two amounts here. We're looking to combine what two percents? There you go, the 64 and the 49. Great. And we're hoping to get a result of what percent? 61. Wonderful. So we're mixing 64 and 49, hoping to get 61. Or trying to get 61. We know the amount of 360 milliliters. That goes with which one? The 61. So this is backwards from the two examples we've done so far. In both of the two examples we've done so far today, we've known the amount of one of the ingredients, one of the inputs. But here we know the amount of the final result. The process is still the same. I'm just going to let the amount of one of these be X. Doesn't matter which one. And I know that this plus this has to equal that. So 360 minus X. Very good. Whatever this one is, what's the rest of it has to be this one. So 360 minus the X is what's left over. So now to write our equation. Again, it's concentration times amount. So 64% is 0.64 times the amount of X, plus 49% is 0.49 times that amount of 360 minus X, equals 61% will be 0.61 times 360 is its amount. And now we go about simplifying so that we can solve the equation. 0.64x does not change. Here we got the parentheses, nothing to do inside the parentheses. So we're going to have to distribute the 0.49. 0.49 times 360 is what, 176.4, I believe. $176.4. And 0.49 times a negative x is a negative 0.49x equals 0.61 times 360. $219.6. Now I can't quite solve it yet because the variable still appears twice. But I've got 0.64x and negative 0.49x, both on the same side of the equal sign. So I can just combine them. So 0.64 and a negative 0.49, or you can think of it as 0.64 minus 0.49, is 0.15x. We still have the positive 176.4 equals 219.6. And now we go about solving it. What do we do first? Subtract the 176.4. So it's gone. We got 0.15x. Over here, what do we have? 43.2, I believe. Then what? divided by 0.15. So 43.2 divided by 0.15. So 288. So x is 288. So again, we have to go back and make sure we've answered our question. So x is 288 milliliters. That's the amount of our 64%. But we're asked how much of each. So we need to figure out the 49%, which will be 360 minus 288, which will be 72 milliliters. So 72 milliliters is the 49%. I'm going to have you guys try one of these on your own, see how it goes. So I'm going to give you a couple minutes. I'm going to go back to our first type here. It's a little bit simpler. How much 57% solution would you mix with 24 fluid ounces of 30% solution to create 48% solution? So I'm going to give you a few minutes to try that on your own. If you need to discuss it with the person next to you to get yourself moving along, that's fine. But I want to see how you can do on these on your own. Okay, let's see how you're doing here. So we're mixing 57% and 30%, trying to create 48%. And we have 24 fluid ounces of the 30%. So I need to know how much of the 57% we're going to add in. So the total amount will be x plus 24. So you got 0.57 times x plus 0.30 times 24 plus, equals 0.48 times x plus 24. Now I'm going to stop right there. Is there anybody that did not get to this equation? Because I'll go back over how we got it if we need to. So everybody made it to that equation just fine? Perfect. So next, then we have to simplify the equation. On the left side, there isn't a whole lot to do here. The 0.57x is just 0.57x. 0.3 times 24 is just 7.2. Over here, we have to distribute the 0.48 through the parentheses. So 0.48 times x is 0.48x. 0.48 times 24 is 11.52? 11.52. So now that we've got it to that point, we have one more step before we can start to solve. There's an x on each side, so we have to get rid of one. So the smaller one here is the 0.48x. I'm going to subtract the 0.48x. So that leaves me with 0.09x here, plus 7.2 equals 11.52 is all that's left on the right side. We'll subtract the 7.2. 0.09x equals 4.32. And finally, we'll divide by 0.09. So x equals, what do we get, 48? So then we go back up. X is 48. Fluid ounces is the unit being used there for our amounts. And that is what we're asked for, is how much? 57%. How many of you got the 48 fluid ounces? Getting a lot better? Good. Okay. Any questions on these? I mean, I want to move on to something a little bit different, but I know these are tough. If you give these a try this week and you're still having problems next week, ask me and I'll do another example or two next week on it. Okay, well, our next step then is we want to look at solving these complex equations we've already solved. We can run into some like this. Now remember, when we did order of operations, we talked about this fraction bar. And it's telling us that you had to do everything on top first, then everything on bottom, and then divide. So when this equation was built, there were actually three things done to the variable. What was done to x is it was first multiplied by the 3. Then the 13 was subtracted from it. So that completed the enclosing symbol portion of the fraction bar, doing everything on top. Then we had to divide everything by 2. So when we go to solve it, what's the first thing we're going to do to remove? The dividing by 2. So we're going to multiply by 2 to get rid of that. So if we multiply by 2, it gets rid of that dividing by 2. We have to multiply the other side by 2 as well. So on the left side, all it did was remove that dividing by 2. So we still have 3x minus 13. Didn't change that at all. Just remove the denominator of that fraction. Over here, 4 times 2 is 8. And now there's an equation we've solved several of. We're going to add the 13. 3x equals 21. And finally divide by the 3. So x equals 7. One application of a formula similar to that is body mass index. Body mass index is weight in pounds divided by your height in inches squared times 703. So we've applied formulas before, plugging in numbers into the plugging numbers into where the variables are. So if we have a patient that has, let's say, a weight of 220 pounds and a height of 71 inches. The body mass index, BMI, found by plugging in 220 for the weight. Height is 71, so it's going to be 71 squared, and then times 703. So to solve this, we first have to do, there's nothing to do on top of the fraction bar, so let's do 20. Next we'd look on bottom. 71 squared is, what, 5,041? Perfect. Thank you. Then times 703. So now we would have to divide and then multiply. I'm going to go ahead and just punch this all in my calculator. 220 divided by 5,041 would be 0.0436, then times the 703. So we'll just go 30.7 is where we'll round this one off. So a BMI of 30.7. But what if we had a patient who had a height of 68 inches and a BMI of 29. And we wanted to know, go backwards, figure out what was this person's weight. I'm just going to put W up there for weight. Height squared, 68 squared, times 703. So we have only the one missing variable. The W here is all we need to find. We have to solve this equation. And there are a couple of different ways we could go about doing this. The simplest way is to just look at it the way we just combined the formula up here. We had to square this first, and we're going to have to square that first here anyway, because we do have to simplify whatever we did. But then from there, think of this value here, which was the weight, as being our variable. What happened to that number? Well, it was first divided by the 5,041, divided by that height squared. Then it was multiplied by the 703. So to solve this equation here, we're going to have to divide by the 703 and then multiply by that height squared. Before we start doing that, though, we do have to square the height. 68 squared, 4624. So now we will divide by 703. Make that go away. So now I'm going to keep this in the calculator because 29 divided by 703 is going to give us a really ugly decimal. If we write it down and try to type it back in, it's going to have a round off error in it. So what I'm going to do is just this. 29 divided by 703 is going to give me 0.04125. I'm just going to leave that in the calculator. I'm not going to hit clear. That equals my W over 4,624. Because my next step is going to be to multiply by that 4,624. Leaves me with just W on the right side. On the left side, I still have that 0.04125 blah, blah, blah in my calculator. So I just need to multiply by the 4,624. I get 190.75. I'm going to round to 190.7. It was 190.74, so I'm going to round it to 190.7. Must be the weight of that patient. Any questions? Okay. With that, then, we're going to put the equations aside for a little bit, and we are going to start talking about ratios. A ratio is nothing more than a comparison between two numbers. An example we could have of a ratio would be for this class, students in New Richmond compared to students in Rice Lake. There are 10 students in New Richmond and 4 in Rice Lake. And I can write it like that as a fraction of 10 over 4. Or I can write it as 10 colon 4. Or I can write it out with words as 10 to 4. Now, often I like to leave it like this as 10 over 4 as a fraction. Because in fractional form, there's a lot of things I can do with it that are very, very similar to what I do with fractions. For example, both 10 and 4 can be divided by 2. I can divide that out to make it a 5 to 2 ratio. Now I could do the same thing in either of these other forms. I'm used to doing it with fractions. So it's easier for me to do it in that fractional form. Now, one of the differences between a ratio and a fraction, that is 5 over 2, I would not change it to 2 and 1/2, because then it wouldn't be a ratio anymore. A ratio has to compare two numbers. So that ratio needs to stay as an improper fraction. Never change a ratio to a mixed number. Now, a bit of a note on this right here. If we write it out in words, there are actually two ways of writing a ratio in words. And I used one of them here. The appropriate way for this ratio is 10 to 4, or if I reduced it, 5 to 2. When I use the word 2, that means I am comparing to, the word is disjoint sets. By disjoint, I mean there's nobody that's a student in New Richmond and a student in Rice Lake. They're completely separate. But they are parts of a whole. In fact, they're the only two parts of a whole. I could have done a similar ratio here to compare New Richmond students to total students in the class. And that would have been, of course, 10 to 14. I should use 10 to 14, 10 out of 14, which could be reduced to, of course, 5 out of 7. Now you'll notice I corrected myself and I used the words, instead of 5 to 7, I used the words 5 out of 7. The reason I did that, when the wording is done like this is part of a bigger set. This is the whole set. The 5 here would be included in the 7. Does that make sense? So from this, I can always make a new ratio. If I know that New Richmond is 5 out of the 7 students, I know then the ratio would be 5 to 2, because if there's 7 total, 5 are in New Richmond, 7 minus 5 gives us 2 that are left over elsewhere. In this case, in Rice Lake. And we're going to use that type of ratio a lot in our next unit when we talk about dilutions. A dilution is a ratio of, we're just going to use the generic term serum, which is a medication or a concentrated solution like blood or urine. And we're going to be mixing saline. That's where we're going to use that term NS, which could mean normal saline, neutral solution, sterile water, basically. Anything that's non-medicinal, has no medicinal value. And in a dilution, it compares serum out of a total. And we'll look at this quite a bit in the next unit. If we have a 1 in 7 dilution, that means we have a ratio of serum to total solution of 1 to 7. Just like I did up here, if I wanted the ratio of serum to saline, it would be 1 to what? 6. There we go. 7 represents our total solution. If one part is serum, the other 6 parts have to be the sterile water, the saline. Now, if I look at the tables in the room here, you have similar tables there in New Richmond. These tables are 18 inches wide and 72 inches or 6 feet long. So I have a width to length ratio. Now I could have done a length to width ratio and just flip it over, but in this case I'm doing width to length. Both of those, the inches divide out, both the numbers can be divided by 18, gives me a 1:4. You'll notice there are no units here. So you might ask, well, what is that? Well, it really doesn't matter what the units are. It's 1 unit to 4 of the same units. So it doesn't matter whether I have 1 inch of width compared to every 4 inches of length, or 1 foot of width compared to 4 feet of length. For whatever unit I'm measuring the width in, there will be 4 times that many units in the length. You'll also notice in all the ratios I've done so far, the labels have been the same. Here I'm comparing inches to inches. Here I'd be comparing milliliters to milliliters. Up top here I'm comparing students to students. In a ratio, you must compare 2 things that have the same label, have that same name. If I had something like 2 feet to 18 inches, that's not a ratio. Now, fortunately, I can change 2 feet into 24 inches, and now I am comparing inches to inches. Now it is a ratio. So the inches cancel out. Both 24 and 18 divided by 6, which gives me a 4:3 ratio. We do, however, often run into things that cannot be converted like that. For example, let's say we go on a road trip and we drive 365 miles in 7 hours. There is no way that we can convert miles into hours or hours into miles. This is not a ratio because the labels will not be the same and we can't make them the same. So this is what is called a rate. So the first difference between a rate and a ratio is a rate compares 2 numbers with different units, and a ratio always compares 2 numbers with the same units. Because of that, the ratio is going to not have any units in the result. The rate must have the units still in it. The second thing is ratios we often would leave like this. 4:3 is just fine for us. Up here we had a 5:2 ratio. That's just fine. There is something called a unit ratio. A unit ratio you divide out by the denominator. So you divide by 3 here. 4 divided by 3 is 1 1/3. 3 divided by 3 is 1. So that could be called a 1 1/3 to 1 ratio. Notice it's still 2 numbers. Compare, it's just the bottom number, the last number is always 1 in a unit ratio. Ratios, however, it's very, very common to leave them just like this. In a rate, we almost always convert it to a unit rate. So that means we're going to have to divide out the number on bottom, not necessarily the units, the labels. We divide 7. 7 hours divided by 7 is 1 hour. 365 miles divided by 7 is 52.142857143 approximately miles. What's that tell us? Well, if I rounded it to 52.14, that's saying in 1 hour I can go about 52.14 miles. Often we actually rearrange these rates so we lose this appearance of the fraction here, and the appearance of the fraction is actually pushed into just the units. So we write it as 52.14 miles per hour like that, so the fraction gets pushed into the units. In fact, a lot of times we get rid of the appearance of the fraction altogether. For example, let's say on this trip we get 50 or 24 mpg. What's mpg stand for? Miles per gallon. There isn't a fraction appearing there, but there really is one there. 24 miles per gallon means 24 miles to 1 gallon. So when you see this, you need to be thinking this, because this is the form we're going to need it in to calculate with it. Okay, it is time for our break, so let's go ahead and take a 10-minute break. It's 9:20, so let's come back at 9:30.